Geometry, section 11.6, surface area and volume of a sphere. I have a globe in my classroom for this very lesson. If you were here, I'd be holding my globe right now, and we'd be talking about spheres in real life. So there's going to be some vocabulary with this lesson, and I could make the notes really long by defining each one, but I think you're going to know these terms. And the first term to know is sphere itself. Think of globe or basketball or something like that, and you know what a sphere is. A sphere has a center. One way to define a sphere is to say it's a three-dimensional circle. I don't think that's the best definition, but it's a good way to think about it. And a circle has a center, right? Two-dimensionally, a circle has a center. Well, a sphere also has a center. In fact, a good way to define circle is to say that it's the collection of points that are the same distance away from a given point. That given point is called the center. Well, a sphere, three-dimensionally, is the same thing. It's the same distance from this point center, this point that's called center, to anywhere on the surface of the sphere, okay? So, just as an example, I've done the best I can to draw a three-dimensional figure on this two-dimensional screen. So this is supposed to be a sphere. This curve is supposed to give it some three-dimensional depth. I hope I pulled it off. This point right here is the center. And each distance from that point, like this one, or this one, or if you understand the three-dimensional nature of my drawing, coming out towards this right here, anywhere to the surface, anywhere, would be the same length, okay? Now, that length any of those line segments that has that consistent length has a name also, and that would be, of course, radius. All that we know about two-dimensional circles is being applied now to three-dimensional sphere, okay? And also, if a sphere has a radius, then it's going to have a diameter as well. That would just be doubling the radius, okay? So I've put 4 words out there so far: sphere, center, radius, and diameter, and then I have a few more. Something called a great circle. Now again, a globe is a good example for this, and the equator on the globe would be a good example of a great circle. Okay. Also, all the lines of longitude on a globe would be great circles. Basically, it's just the largest circle that can be drawn. Okay. Now, if you read this in your book, it would say that it divides the sphere into 2 congruent parts. That's another great way to define this. If you think of like the parallel lines on a globe, other than the equator, those are not great circles, right? They're smaller than the great circle. Now, by the way, I do know that the Earth isn't an exact sphere. It's pretty close. But the globe that I have in my room, as far as I know, is an exact circle. And for that reason, then, the equator is a good example, and the lines of longitude are good examples. Okay, so that's great circle. You need to know what a great circle is because a sphere also has a circumference, and its definition is that it's the circumference of a great circle. Okay, so again, if you think of like the parallel of Capricorn, that's the one I can think of, is something smaller than, shorter than the circumference of the Earth at the equator, right? That's not the circumference of the sphere. The circumference of the sphere would have to be at the equator, or again, one of the lines of longitude, or something else, but again, it has to be as it divides the circle into 2 congruent parts. Finally, then, a word that you probably have heard is hemisphere. And a hemisphere is simply one of the 2 parts. If you have a great circle and it cuts the sphere into 2 congruent parts, those 2 parts are each a hemisphere. Okay, so formulas. We're doing surface area and volume of just one object. Understand that the cadence got a little bit different. We were doing multiple objects, surface area, multiple objects, volume. Now we're just going to do one object in this whole section. It's spheres, but we're going to cover both surface area and volume. Surface area is 4 pi r squared. The volume is 4/3 pi r cubed. Both of them use the radius r, so we'll have to be given that information or have the ability to find it. So here's an example. It says find the surface area of the sphere and leave your answer in terms of pi. That 18 is clearly a diameter, so the radius is going to be 9. And our surface area is 4 pi r squared. The r is 9. Leaving our answer in terms of pi, all I have to do is square 9 and multiply it by 4. That would be 324. So our answer is 324 pi, and it is a surface area, so feet squared. Here you have the circumference of a rubber ball is 13 centimeters, and they want us to calculate the surface area. Notice the difference. They didn't give us a diameter or a radius. They gave us the circumference. Now that is to be assumed the circumference of a great circle then. The circumference of a sphere is the circumference of a great circle on the sphere. So we have a formula for circumference. We have a two-dimensional formula for circumference, and that's what we're talking about. We're talking about the circumference of a circle that could be extracted, if you will, from this ball. And that formula we learned in chapter 10 is 2 pi r. And they gave us the circumference. So can't we solve this for r? We could by dividing both sides by 2 pi. And you can do it one at a time if you want to. I think you should just do it in one step. Divide both sides by 2 pi. So r would be equal to 13 over 2 pi. Okay? Now, caution. If you take your calculator right now and you divide 13 by 2 pi, if you type in these 5 keys, 1, 3, divide 2 pi, you will not get the right value. Your calculator would interpret that as 13 divided by 2, which is 6.5, and then multiplying 6.5 by pi. You didn't want to do that. You wanted to divide by pi, not multiply. So if you're going to type that into your calculator, what you should do is put parentheses around the 2 pi. Okay, now better than that is I'm not even going to type that into my calculator right now, but rather I'm just going to put this right into the surface area formula, just as is 13 over 2 pi. The surface area formula, 4 pi r squared, would be 4 pi times 13 over 2 pi squared. We found the radius to be 13 over 2 pi, so I'm typing that, or I'm inserting that into my formula for r. Okay, now here's where you do have to be really careful. And I'm going to click over to my calculator and we'll do this together. That was 4 pi times 13 over 2 pi squared. And this is a graphing calculator. If you have a handheld TI-30 or whatever, it's going to work very similar to this. You want to type in 4 pi, open a parenthesis for your fraction. That would be 13 divided by, open another parenthesis for your denominator, 2 pi, close that parenthesis that closes the denominator, and then close the outer parenthesis that closes the fraction, squared. This is going to give us the correct answer. That's 4 pi. R is all this right here. The 13 divided by parenthesis, 2 pi, close parenthesis, is the radius. And then that's being squared because what's the outer parentheses is what's being squared. So our answer would be 53.79, etc. I think they said round to the nearest whole number, so 54. Yep, nearest whole number. 54. The circumference was 13 in centimeters. We found a surface area, so centimeters squared. Okay, now let's deal with volume. Find the volume of the sphere, leave your answer in terms of pi. Volume is 4/3 pi r cubed. And don't confuse those two things. Squared naturally goes with surface area, and cubed goes with volume. That should make sense because of how many dimensions there are, right? Volume is 3 dimensions, not just 2. Surface area, even though it's on a 3-dimensional object, is still a 2-dimensional calculation. So that's how you keep them straight, because it's r cubed, r squared. The r here would be 15. So the work to be shown would look like that. I'm going to grab my calculator real quick, and I'm going to do 15 to the third, and I'm going to multiply that by 4/3. A few different ways you could do that, but you should get 4,500. 4,500, and leave it in terms of pi means I'm bringing the pi with the answer, and 4,500 centimeters cubed. Okay, now I don't think we've done anything too difficult so far. This last one will challenge you a bit. So if you have to pause it and go eat a bowl of Wheaties, come back to this. I understand. It says the volume of a sphere is 1 cubic inch. Find its surface area to the nearest tenth. So now we're being given volume, and we want to find the surface area. Okay, well, we have a volume formula that is 4/3 pi r cubed, and they're telling us that volume is 1. Now, I'm going to roll to some of their answers here, and then I might fill some things in. Here's our formula, they're plugging 1 in for the volume. Okay, now what do we need? Well, our formula for surface area is 4 pi r squared. We need the r. We need to figure out the radius. And here's a formula that we can solve for r. What I would do is multiply both sides by 3/4, because that would cancel these fractions. Then I would divide both sides by pi, so you'd have 3/4 is equal to pi r cubed. I think I'll just take over from here. I would divide both sides by pi. Now, I could go into a demonstration for this, but just to keep the video at a normal length, I won't. When you divide a fraction by something, it puts it into the denominator, right? 3/4 divided by pi is like saying 3 divided by 4 pi. So the next line here would be this. Okay, now let's take a little detour over to the calculator again, because you need to be able to know how to cube root something, right? You know that square and square root are undo operations. Well, the same thing is true for cubed. Cubed is that it has an undo operation that is the cube root. Okay, now if you have a TI-30, if you have a scientific calculator, this is going to look a little different, but the function is nearly the same. Okay, if you have a graphing calculator, it's under the math function, and there's a symbol right here for cube root. What I want to point out to you is that there's also a symbol that looks like this. Okay, and if I select that, because I have a nice new calculator here, it'll allow me to do this. I can put the number here. For your handhelds, what you would want to do is put a 3 first. And I think it's on the left panel somewhere, one of the top buttons on the left column, I should say. You'll see that symbol. Want to see it again? It's this symbol right here, the X root. And again, what I just did there by typing in 3, if you then select that button, which is going to be second, and then that button for you all, it'll put the 3, it'll assume the 3 goes in for X. Okay, and I can't demonstrate this perfectly because I don't have the ability to show the TI scientific calculator, but that's what it'll do. So you'll type in 3. That was weird. It didn't let the 3 stay there. Let me try that again. 3 math. Yeah, that's what it'll assume it does. Now your screen is not going to show it the way this one does, because this is just an upgraded operating system, but that's what it'll do. Okay, now the best thing to do would be to try this problem along with me and make sure you get what I get, or what the software here gets. So literally what we're doing is we're taking the cube root of both sides here to get r by itself. So r is the cube root of 3/4 pi. Okay, now I'll leave it up to you. You know you best. If you want to do what I did on that problem in example 2 and leave it like this and plug it into the problem, you can do that. That would be perfectly fine. If you want to go to decimal, that's okay too, but use a long decimal. If you're going to type in a long decimal, you could also use some of the save features on your calculator. I can't get into all that right now. Maybe you know what I'm talking about, but you kind of have the option there. So let me show you what they did, because it is one of the options that I just said. So they did go to decimal. All right. Now, again, you could store that and then take that over to the surface area. You could just write out a long decimal, 0.62035,049, and that's what they're going to do. So there's the surface area formula like we've already done, and they just used a really long decimal. Okay. And it does make a difference. If you use just 0.6, you might get a different answer. So I would encourage the long decimal. And then at this point, or again, if you have it on your calculator, you could just go squared, enter, times 4 pi would also work. Okay. Few different possibilities there, and comes out to about 4.8. And again, before you do the homework, I would highly encourage you to at least do this problem on your calculator. Make sure you've got the keystroke down correctly. All right, thanks for tuning in.